Hello. In this video, we will continue with our study of Chapter 9. We will cover the method of formal hypothesis testing when we have two means and an independent sample. Again, in this section, we will present methods for doing hypothesis testing for claims made about two population means and construct confidence interval estimates between the difference of those population means, just like we did in the previous video for population proportions. We have dealt with the topic of independence and dependence before, but because we're dealing with two samples and talking about testing a claim on these, it warrants further investigation. Two samples are independent if the sample values from one population are not related to or somehow naturally paired or matched with the sample values from another population. In this section, we will be dealing with two samples that are in fact independent. The counterpoint to independence is what we call dependence. And here, two samples are dependent, or we can consider them as matched pairs, if the sample values are somehow matched, where the matching relationship is based on some inherent relationship. This will be the topic of the next video, testing a claim about a sample mean that is matched with a separate sample mean. But for now, we will consider ourselves restricting to the independent case. And with that said, we have two main objectives. One is to actually do the formal method of hypothesis testing, to conduct a hypothesis test about a claim made for two independent means, and build a confidence interval estimate around the difference between those two independent population means. Before we move on, explanation of the notation warrants some time. So again, we're using the notation for means, where mu is our population mean, x is our sample mean, sigma is our population standard deviation, s is our sample standard deviation, and n is the size of our sample. And because we have two samples, we're going to index or put little subscripts around each of these things. So again, mu sub 1 will refer to the population mean of the first sample, whereas mu sub 2 will refer to the population mean for the second sample. Just like with all hypothesis testing, there is some initial requirements. All of these requirements we will meet in our examples for simplicity. But if you recall from confidence intervals, there were two different versions, one where we knew the population standard deviation and one where we did not. And so our requirement will be this, that our population standard deviations will continue to be unknown, right? And so everything we do today in this video will be using that assumption. Every form of hypothesis testing needs a test statistic. And for mean, if we recall, we have a t test statistic instead of the regular z one. Here is our test statistic. It's the sample mean minus the sample mean of the second, minus the quantity for the population mean of the first sample, minus the population mean of the second sample, divided by S1 squared over N1 plus S2 squared over N2. And again, we may not know the population means, but again, our null hypothesis for every one of these examples will still be that mu1 is equal to mu2. And if I have two values that are equal, mu1 minus mu2 is going to be 0. So that parentheses will always, in this case, end up equaling 0. If we recall from Chapter 8, when hypothesis testing about a mean, we needed a degrees of freedom. Because we were dealing with a t-test, we needed to know the degrees of freedom for our sample. However, now we have two samples, and so we can use one of two methods to compute the degrees of freedom. And we will use this first case. It is a simple, more conservative estimate. The degrees of freedom will be whichever is smaller, n sub 1 minus 1 or n sub 2 minus 1. That will make it much easier to compute the degrees of freedom. Just like with before in hypothesis testing, we can use the p-values method or the criticals value method. And if you recall from Chapter 8, it is much easier to do hypothesis testing on a mean when we restrict ourselves to critical values. So that's what we will do. We will have to build a critical region where our t-distribution is built off of our significance level. And we'll see that as we do an example. Our second main objective is to build a confidence interval estimate around the difference between the two population means. And if you recall from the previous video, we can build a confidence interval around two samples as long as we take their difference. And that's exactly what we're doing here. If I want to build a confidence interval around population means, I will just take the difference of the sample means and subtract the margin of error, and the difference of our sample means and add the margin of error. And down here, we see our margin of error formula, right? Everything we will have from the problem, the only thing we may have to compute again is this t sub alpha over 2. But we compute this exactly the same as in chapter 7, right? That t sub alpha over 2 will be computed exactly the same way. Let's look at an example. Listed below are student course evaluation scores for courses taught by female professors and male professors. We will use a 0.05 significance level to test the claim that the two samples are from the populations with the same mean. And so what we want to see is, does there appear to be a difference in the evaluation scores of courses taught by female or male professors? For some of the examples in the homework, you may have to compute each sample mean and each sample standard deviation. But for any examples we have to do on an assessment or a final, I will give you the sample mean and sample standard deviation for each of the samples. So we can see the mean of the female set is going to be 3.867 with a standard deviation of 0.563, and the size of that sample is 12. Whereas the mean score for the men is going to be 3.993 with a standard deviation of 0.395, and the sample size is 15. So here, let's use these values to do the formal method of hypothesis testing. Whenever we do hypothesis testing, we need to understand the claim made in the problem. And the claim is that the two samples have an equal population mean. And so if we look at our original claim where mu1 is equal to mu2, and I look at the opposite of the claim, mu1 is not equal to mu2, I can look at my null hypothesis and my alternative hypothesis. Again, the null hypothesis will always be the one with equality, and the alternative one will always be the one without equality. Here are our two hypotheses. And what we want to understand is whenever I see an alternative hypothesis of not equals, that will tell us that we are going to have a two-tailed test. Let's quickly review what we mean by a two-tailed test. When we have a two-tailed test, we get our significance level of 0.05 in this problem. And the two tails refers to our area that marks off the critical region, that we will have an area to the left and an area to the right that contains our total significance level. And if our value is 0.05, that value has to get split equally among those two regions. So this region becomes alpha over 2, or 0.025, as the same as the area to the right. Because we have two markers for our critical region, we're going to get two different critical values, a positive value for t and a negative value for t. And what we want to remember is these t values will be exactly the same but opposite signs. Whenever we have a two-tailed test, we want to remember we don't have a singular critical region. We have two opposite but equal critical regions. So when we do our calculation for our test statistic, what we have to make sure is that this test statistic will fall in either of these two critical regions, either the one to the left or the one to the right. As long as that test statistic falls in either one of those regions, we can reject the null hypothesis. So let's figure out our critical values, the t value and the negative t value, which have an area all the way to the left of 0.025 and an area to the right of 0.025. And again, because we're doing a t-test, we have to look at our student t distribution chart. Here is our student t distribution chart. And if we want to remember, our significance level alpha is 0.05. That is the total area in both tails. So our area in two tails is 0.05. That tells us we are looking at that middle column. And to find our critical value, what we want to do is look at the degrees of freedom. But because we have two samples, right, N1 is size 12 and N2 is size 15, I have to use my estimate for my degrees of freedom. And we said to do that, the degrees of freedom, we would subtract one from each sample and take the smaller of the two values. So we will use 11 as our degrees of freedom. And with an 11 degree of freedom and an area in two tails of 0.05, we get a t-score of 2.201. So what that reinforces is that both of these critical values that mark off our critical regions will be 2.201, but the one to the right will be positive 2.201, and the t-value to the left of my middle of 0 will be negative 2.201. Now we can compute our test statistic and determine whether or not this test statistic we will find falls within either of these two critical regions. To compute our test statistic, we want to have these 6 pieces of information ready. Our 2 sample means, our 2 sample standard deviations, and the size of both samples. And we look at our formula for the t-test statistic here. If we plug our corresponding values into the test statistic formula, remembering that mu1 minus mu2 is assumed to be 0 by our null hypothesis, we compute this, we'll get negative 0.660. That is our test statistic. So let's look at our critical region again and see where this test statistic falls. Here is our critical region with the critical values of 2.201 and negative 2.201. And we computed our test statistic to be negative 0.667. If I look as where that will go in our number line, that will fall fairly close to 0, about right here. And we can see our test statistic is outside of the critical region. So what can we conclude from our formal hypothesis test? Because our test statistic is outside of the critical region, we fail to reject the null hypothesis H sub 0. And the interpretation, based on our original claim, is that there is not enough evidence to reject the claim that there is no significant difference in course evaluation scores between male and female professors. That there actually could be no difference between the scores. That is what our formal hypothesis test will tell us. Let's move on to conducting a confidence interval around the difference between these means. Let's use the previous data to construct a 95% confidence interval estimate between the difference of the population mean course evaluation scores. Here are the values from our samples. Our sample mean for the first sample, again, is 3.867, and the sample mean for our second sample is 3.993. And we can see, moving on, what those are. Below is our margin of error formula. And if we recall, we computed t sub alpha over 2 to be 2.201. Now we can plug in and compute the margin of error. If we plug the appropriate values in, we should get a margin of error of 0.422. Let's build our confidence interval given this margin of error. To build the confidence interval around the difference between the two population means, we will take the difference between the two sample means and subtract our margin of error, and the difference between the two sample means and add our margin of error. If we compute the difference between the two sample means, we'll get negative 0.124 with a margin of error, again, calculated previously, of 0.442. Therefore, our lower bound for our margin of error for a confidence interval, which is negative 0.548. If I look to compute the upper bound for my confidence interval, I'll take the difference between my two sample means and add the margin of error, And if I do that, I'll get 0.296. Thus, my confidence interval will have a lower bound of negative 0.548 and an upper bound of 2.96. That is our 95% confidence interval built around the difference between these two sample means. Hopefully this video was helpful. Again, if you have any questions, feel free to contact me. If not, I will speak to you next time.